Hello, mic check. Yes.
Check, check.
Check. So thank you W.Media for arranging this and inviting us, and thank you Sreedhar, Shivang, and Thamarai for making time for this panel in the middle of your working day. And two of you have traveled from outside Chennai, and you have traveled from a distance which is equally like outside. So thank you for that. And I will take a moment to introduce my esteemed panelist. Mr. Sreedhar Gade runs all of tech for Freshworks in India and around the world. And he's a very senior tech leader with pedigree in Microsoft and other companies, recently in Freshworks. And he's the head of platform engineering, site engineering at Freshworks. Shivang runs an AI company called Dragonfruit.ai, and which is a boutique AI firm. So there are many underlying companies within the Dragonfruit platform, which we will tell you later as we get deeper into introductions and conversation. And he is doing some path-breaking work, especially around AI at the edge, and which is the topic here. And edge devices and all of that, we will learn more with him as we go deeper in the conversation. And Thamarai is at Montra Electric. He is the head of cloud engineering there. And very importantly, they have launched three-wheelers which are on electric. And the IoT platform entirely is architected and operated by him. So that's a high-level introduction. So at this point, I will dive straight into the conversation. And first questions goes to you, Sreedhar. As AI adoption accelerates across digital native businesses, how are cloud and data center infrastructure requirements fundamentally changing? As in, what was your cloud and infra expectation yesterday? What is now? And where do you see it going 3 years to 5 years into for your own company and then as an industry?
As you can imagine, we are going through a tremendous transformation. So I'll talk about past, present, and future. Right? In the past, it's all about cloud is compute storage network, and then data. That's about it. So it's all about scale. So I work for Microsoft, a very large scale Dynamics platform, 6 billion revenues. And then prior to that, Yahoo, a very early stage of cloud. It's all about very linear growth. It's all about what is your data residency, right? What kind of load do you need in different geographies, and how are you going to support your customers? Maybe it could be different languages or different scale. That's about it, right? So then we've transformed to kind of ML world. This is like a pre-generative AI world. ML world is where we started talking about GPU machines and start training our internal in-house models to automate workflows, create some kind of a hyper-personalization. But this is all like an in-house ML game. Now with the generative AI, now we are talking about entire business logic moving from our compute, our code, into the model itself, or the agentic.
Wow.
Agentic framework that we have, platform.
Got it.
Which basically means you should be able to plumb all these frontier models like Anthropic or OpenAI or Llamas, right? Also the self-hosted models that you are training within your network. And then CPU becomes only number 3.
Okay.
So there is hosted models, which is basically managed models from all these large companies. And then you have self-hosted models which on GPU clusters that we have like H200, H300 machines. And then you have the CPUs. So in the whole process, what we started doing is we created something called a model fabric service, which basically is think like an intelligent model load balancer, which basically orchestrates a user traffic. And it decides should it go to traditional CPUs, or should it go to GPUs, or should it go to the models, depending upon type of use case. So yeah, I mean, the demand on us is multifold, and innovation in the cloud space is kind of multiplied as well.
How do you keep tab on what is coming next?
So our team has to be at least 6 months ahead of the rest of the engineering team, which means that we are working with you, we are working with Anthropic of the world, we are working with the Googles and Microsoft, all the AI hyperscalers, so-called, and they give us the preview of what's coming in next 6 months to 1 year. For example, Amazon tells us what is coming in December. So we are kind of preview partners or launch partners, and then we kind of experiment with what is coming and be ready for the requirements of this future.
Thank you. So now to you, Shivang, what does an AI-ready data center truly looks like in terms of compute density, scalability, connectivity, and operational resilience?
Okay, this is a very broad topic. So
Yeah.
let me first, so I am not a data center operator, but we use data centers, right?
Right.
So we use compute. And my hypothesis, and I have been in computer vision industry for more than 7 years now, when no one knew about generative AI even, right? So, and that too in real-time computer vision, not a computer vision where you upload something and then you uh, get the details, right? So it's a different kind of industry, and I want to give a, a brief around this because how we think about artificial intelligence evolving is a little different than generative AI. So how we think about it is uh, it starts with generative AI because internet data is the most structured data which is present. Then it will go to computer vision where we'll start to see a lot of data being, AI being used in the video data. And then it will go to the spatial, and that's when the robotics will come in. So we feel that in 5 to 7 years, robotics will be the main thing. And why I'm talking about this? Because this is slowly going into the phase of real-time inferencing, right? We have been using GPUs mainly for training at this point of time. So data center needs to think about training and inference as the two different set of computes that they need to provide. Till now, I've been hearing a lot of conversations here around GPU rack, racks,
Density.
rack densities and all of these kind of things. But we really need to think about inference as a separate
Subject.
compute uh, as compared to like GPU stacking in data centers for training purposes, right? So I feel the evaluation will happen in a layered manner where main data centers will always be there with lots of GPUs, etc., for training. Then there needs to be localized colos because we need real-time inferencing. So let's say robot needs to make some inference. It cannot go like 200 millisecond up to the main data center and get the inference. It needs to be edge, then local colo, and uh, then the main data center. So I think the future is going to be this layered inference infrastructure that these guys will have to build, and that's where the world is going.
No, no, very profound and deep perspective, and that's what I was talking in the other conversation just before here about edge. So your mobile phone can be an edge, the server in your factory or office can be an edge,
Yeah,
a locality data center can be an edge, a telecom tower, or a data center in a data center park within the city or region can also be an edge.
right.
So far, there is no formal definition of the edge itself. Forget evolving it.
Yeah,
Like hyperscaler and edge, these are two words which have no definition. What is hyperscaler? It is up to everybody's imagination.
right.
Likewise, what is edge? You decide your edge, or you define your edge. And very interesting. And coming to you, Thamarai, multi-cloud and hybrid cloud strategies are becoming reality of digital native organizations. Yours is a physical organization turned digital and now digital native. So, so are they adding unnecessary complexity by having these models coexisting, or is it a reality, multi-cloud and hybrid cloud?
So basically, before explaining or like before providing some information, initially the day started with data center deployments, right? Then we moved to a cloud native solutions. Then people started creating a hype called why we have 10 service providers or like 10 public providers. Why don't we use best services which is given by, there is a new concept called multi-cloud came into the picture. Then there are some of the workloads we want to have in on-prem, some of the workloads we have to do in a cloud, then hybrid cloud came into the picture. See, basically in my point of view, both hybrid cloud and multi-cloud are like very, very important foundations for like digital native apps. But there is a one catch here. So you should not just, because we have a solution called multi-cloud and hybrid cloud, we should not go like that the way which is available. but there should be a clear business requirement should be in place. Or else definitely it will end up in maintaining the ops complexity, it will create an operational complexity. And on top of it, we should have a clear abstraction, kind of like you should have a proper platform engineering and automation systems in place to abstract the layer of this complexity. I'll tell you why. Because like, see, why the importance of hybrid and multi-cloud comes into the picture is like considering the current AI era, we required GPU intense capabilities we required. So some of the cloud providers, whatever we are expecting, there might not be in our native region, the availability of the GPU intense workloads will not be available. So we tend to move to multi-cloud approach. And there is if we go in that way, there should not be a vendor lock-in also. See, for example, if we are going to adopt a single cloud, so we will be end of the day will be in a vendor lock-in period. So, and other thing is like, for example, some of the enterprise which personally we have experienced, they will not accept the data workloads to be moved to the different cloud. They want to have the workloads in their on-prem servers itself. So in these cases, like I could say multi-cloud or hybrid cloud is the best option, because like we should rely on business requirements, right? So this is not a fancy word to adapt, because we have an infrastructure modernization is in place, but it should be a clear justification or like business requirement should be there before we are moving to multi-cloud or hybrid cloud, or else it ends up in operation complexity.
Got it. So it's on the merit of the business use case that you will either decide to continue with one provider or expand your bouquet of.
Exactly, yeah.
Sri, to you, how are fintech, SaaS, OTT, gaming, e-commerce like companies rethinking infrastructure strategies to support real and latency sensitive applications? And same question will come to you also, Shivang, because you are also doing equal work on the same domain, and likewise he.
Yeah, I think, like I said, last decade was all about the basic compute and storage. So there's not much difference in what type of applications are you running. But now, with the scale coming into the place, each of them need a specific design. So let me talk about a basic SaaS or a digital native or ISV scenario, where you basically have a portal or a mobile app and millions of users are able to access. So all you need to care about is your AI workloads. They are coming from all AI hyperscalers. And then you also have work with, you and a few other companies for the GPUs, and then you start innovating. That's one part of it. And probably use CDN and also take care of a security and perimeter security and all that. When we come to the OTT or streaming platforms, the story completely. So you basically offload all of you to the edge. Again, here the concept of edge could be where your CDN is perimeter from or the last mile, right? So from there, if you are able to actually push as much content as possible in that space at a petabyte or like a hexabyte scale, and your user, the latency for your end users is going to be much lower, right? And then you also have a very fluid scale up, scale down capabilities. So if there is a cricket match happening, if there is some major event happening, you might get like 20x more traffic versus a normal day how it's going to look like, on a festival day how it's going to look like. So using AI, we are able to do predictive models which actually looks at historic data and be able to predict the future traffic. So it's a combination of predictive models for predicting your traffic, plus a very good auto scale systems that can actually go up and down, will give more predictable experience to the users.
Got it. And your views, Shivang, on this?
My views are similar to him on SaaS and like how exactly to monitor your traffic, and based off that, like where exactly the predictive models around that to measure the traffic. But if you are looking at AI native products, right? So you should think about AI models exactly like humans, where as a human, I am probably good at 10 things out of 100 and probably can generalize things for 100 of them. But I'm probably good at just 10 of them. right? So for example, if something comes, a question comes to me for architecture, I'll be able to answer. But any law related stuff, I don't have answer. I can probably uh, make a guess, but not really give a profound answer around that. So as a human, what I do is I go to my friend who is a lawyer and then ask specific questions to them, right? So think about models as well in this context. There'll be generic models, which will be on the edge near Colo, which will give you quick reactions to whatever the questions are asked. And then there'll be specialized models, which will be in your data centers running on GPUs, which are large models. So for example, for a specific question like, for a specific question around lawyer that I was talking about, the general model might not have the answer. The request will go to the specialized model. So general model will say, I don't know, let me ask my specialized model and get the answer. So in the new AI native world, we are thinking about building products in this way, where the compute is split based on the type of the question or things that are being asked. So this is a different way of thinking about AI products in general. So so that is adding more perspective to what Sri was saying. So.
Lovely. Thamarai, for you, what role which edge infrastructure and distributed computing play enabling the next generation of AI digital experiences? And you are running autonomous, not autonomous, about to become autonomous electric vehicles on the road. So,
See, basically, when you are talking about edge and distributed computing systems, like both are foundations for our next gen AI era. Because consider like the AI intense applications, whatever we are building, that the real intelligent expected in the data creation layer itself. So instead of like we are collecting the data and we are processing that in the centralized cloud, instead the intelligent currently expected to happen in the where the data is generated itself. See, for example, like we are using a connected vehicle platforms, we are doing the edge computing where like, see, in the AI application layers, what is expected is like millisecond, even millisecond delay is not acceptable, and we require real time analytics, and high processing throughput is required in AI applications. So that is where like this comes into the picture of edge and distributed systems, where most of the data intelligence layer cleaning up the systems happens in the data where it is getting generated, and it is taken into the centralized cloud. So this balance should be happen with the distributed systems. For example, I should not completely rely on the centralized cloud, or even I should not completely rely on the edge system. So this is where distributed system comes into the picture, where like some of the workloads should be handled in the edge, some of the workloads has to be handled in the edge nodes itself, and some has to taken in the centralized cloud and then to clusters. So this is how the distributed system also helps in this native applications. So in my perspective, I could say both are equally important for upcoming AI era. So we need edge processing also, and hand in hand it has to be workload dilution has to happen in the distributed systems also. That's on my view.
so suppose for your vehicles, an operator comes and offers you a platform with 200 edges in India. Will something like be exciting to you?
Yeah, definitely. So already we are
Like today, something doesn't exist, but everybody is trying to envisage and create similar
exactly. See,
platforms.
even we are also doing an R&D on edge computing, because we are trying to get a real-time analytics of data. What we are doing, it is near real-time now. It is like having a milliseconds delay, or like we can see a milliseconds delay in the cloud processing, and we are trying to do in a real-time processing. Means like not even a near real-time, it should be a real-time. So we are also doing R&D on the edge computing. So we are doing telematics devices in the vehicle, and we are fitting that, and we are trying to run the workloads in the AI. So one with the help of AI and the edge. So the only problem is like the processing and the speed where we are doing that edge computing also should capable of handling all these workloads, right? So it is also equivalent hardware capabilities also should be built in. On top of it, like end of the day, cost matters. So when we are going to run this kind of workloads from edge computing AI to enable to distributed systems. Then cloud native systems will be little bit lesser cost than when you're going to the edge and distributed systems. So we need to consider all the aspects. We have to decide.
Got it. So now to you, Shivang. With the growth of high density compute environments, how should operators balance sustainability, performance, and energy efficiency?
Okay, so we have been talking about, a lot of people are talking about teraflop capacity, like each data center that has, right? One of the key metrics that people don't realize that they should actually calculate is teraflops per wattage. That is the actual compute that all the data centers should be focusing on. And I think, and this is a view from my side, contrarian view, that the training will plateau, the compute required for training will plateau in 3 to 5 years. And it will be the inference compute that will be required after that. So a lot of money is being pushed right now for building of these data centers. And I mean, PUE and WUE, like water usage and power usage, is the metric that generally all the data center follows. But teraflops per wattage is something that they should really, really focus on right now to make sure that what they are building is sustainable and energy efficient. And training is probably 3 to 5 years, but after that, it's all about inferencing that the data center should focus on.
And coming to you on the same question, earlier you would sell SaaS as per user per month. Now possibly per query charge. Is something similar getting discussed in your company?
Absolutely, yes, yes. So we started with the seat-based licensing, right? So number of agents, like if I'm a customer support software or ITSM software, how many human agents? Now agents have to qualify whether human or AI agents, right? Yeah. So human agents seat-based license, and that's exactly what we're going to we used to charge. Then from there we went to consumption-based. Is now that we have AI agents, how many sessions can they use in a given time? So we give them 20,000 or 10,000 session packs. So you can actually have, your company can have 10,000 sessions on a customer support agent, and that can be exhausted over a period of 2 months or 1 year, it depends, right? But then here is a fixed cost. So this second model is linked to the consumption and also the COGS. The underlying AI infrastructure that you have, the models that you are supporting, all that is kind of baked into this model. And initially, first 1 year, you don't look at gross margins because that is your innovation time. That's when you want to actually go and get into the market and get the adoption done. Once the adoption is there and then you know that this is the right product, that's when you actually start looking at creating economies of scale. Now we are in the third stage, we call it outcome-based pricing. So customer doesn't care whether I use 10,000 sessions or 20,000 sessions. Have you helped me achieve my outcome or OKR? So if I'm a chief customer officer, my OKR is CSAT of 4 out of 5, right? Or churn rate less than 10%, right? So these are the OKRs. My team will work the entire year to actually make it happen. Now they are expecting the customer support software to actually help him achieve that.
In fact, I'll tell you very interesting. Some of you may know, some may not. This is coming back to where kind of this whole outcome-based pricing started. And I will give the example, it is known to the world. Airtel and IBM, back in 2004, they outsourced IT to IBM. Earlier on, a telecom company will buy billing server and network management server and all that, like a CapEx, and then an IT team will manage it. Or you will hire IBM to do it through an SI or directly. IBM first time came, and then the model followed with Vodafone and all the other telcos. That they made IT cost per call. That time voice was dominating, data was about to happen. So they would say pay 1 paise, if you are charging 60 paise for a call, 1 paise is IT cost. So only matured calls, IBM will get paid. So all the underlying software, hardware, management, call drop, network, you manage. So today we are revisiting that one more time in a all new manner at a much amplified scale. And to your point, in my view, tomorrow a day will come when you will have to make category-wise inference charge.
That's what we are doing, right?
Because, I can, you say inference per query. I can give a gigantic query and your resource will drown. Versus I will give you a simple query, what is the name of the guy? So just quantity or number of queries resolved. It has to be cat A, cat B, cat C, I don't know, compute intensive, more intensive, very intensive.
So those t-shirt sizing, even in one particular query, if my agent is able to solve it's per resolution, I charge them X dollars.
Got it.
But if it is only able to guide you, but not solve the problem, but guide you to the like halfway through the problem, I charge you X. But if I'm unable to solve the problem and it gets deflected to the human agent, then I don't charge. So even in one particular SOP, I have 3 different tiers. So that's where we came is, how do we actually make it like a credit system? There's a kitty of say 10,000 credits they have. And depending upon complexity of the problem, number of credits that will be deducted will be automatically decided. So there's no fixed price. It depends upon if it is resolved X amount, if it is suggested X amount.
I'm saying even within the resolve, what it took you to resolve. 10 minutes of thinking time, 3 minutes of thinking time, 1 minute of thinking time. Obviously, if you have thought for 10 minutes to resolve, that means you have at the back end consumed more power.
That we did, but customer doesn't care.
No, I know. So you will have to possibly price it cat A, cat B, cat C, something like that. Today it is like resolved, unresolved, pay, not pay. But you give a very hard problem to solve, then in mathematics paper it has 16 marks. An objective type question has 2 marks.
Exactly.
So something equivalent will also follow the pricing charts of the SaaS, of the outcome driven products in the time to come. Wow. Now sir, Thamarai, how are enterprises addressing challenges around scalability and security and optimization around AI? Because AI and security are like looking contrary today. Because people want to assume AI is not secure, or AI is immoral, or AI is bad, or it can do something not good, either wrongly programmed or faultily performing, which is called false positive in a layman's language.
See, actually, I want to split this into 2 things, like scalability for AI and security for AI. See, nowadays, now enterprises started thinking the infra scalability from ground up. Like they started now cleaning, erased everything, and they are thinking it is not, the scalability is not like adding compute. It is like a whole lot of thing. We have to do an intelligent system, intelligent scalability, because like we all the since like this is in AI era, all the AI workloads are coming. How intelligent our scaling system is working, it is based on like whatever the platform engineering portal we have on IDP portals, and like how we are doing the GPU orchestration, observability frameworks, what we have built, how the operational systems are scaled. All these are like they are considering. So ultimately, the scalability enterprise systems are thinking. It is much more than adding just a resource to the existing processes. Why this is happening in real scenarios? Like because like I can say, the AI apps require intense GPU workloads, and the workloads will spike massively. The computes will spike massively, and we require extreme high storage for the computations, and it requires more energy consumptions also. So consider all these aspects, and we have to travel in this AI era considering the cost aspect. So we have to think in very precisely and intelligently. So one thing organizations started adopting is like AI ops, like where they are doing some predictive scaling, anomaly detections. When one good thing is on the security, that anomaly detection part I will take it later. See, predictive automation, predictive scaling, intelligent fixing the issues intelligently, how we are fixing the issues autonomously. All these things are coming into the picture in terms of scalability. So ideally, organizations are thinking in 3 different ways. They want a self-scale mechanism, and self-decision mechanism, and self-healing mechanism. That's what enterprises are moving towards. In terms of security, see, if if we are thinking, AI, the workloads which we are using or adapting is like not secured enough, then we are out of the race. So initially when we started in the public cloud, so we tend to move all the workloads to cloud. The same question arose at that point of time also, like, so how can I give all my data to public? Similarly, the AI workloads happen the same way, right? So when we are giving the all the public available LLM models, we are writing the data on top of it. So we are concerned about the security, right? So we have to, though we have other security models in place, we have to implement our own security models to ensure the data is secured enough on system, which takes care of like all the anomaly detections and writing an AI secured layer on top of workload. This enables us to provide the applications more secured as well as we scale. I think like I have split into these two answers. So basically, scalability is right decision, like intelligent decision making, not adding the compute as a workload. Security, it also should be an intelligent mechanism where we need to secure the workloads. So this is what I say in my view.
Lovely. Now coming to you, Shivang, around architectural shifts and investments. So, looking ahead, what kind of architectural fundamental shifts in the way, let's say the work is defined first and then the resources will follow. And then investment will be the third thing. Do you envisage? Meaning, today it's all about, get me more power, so I will produce more. And get me further more power and I will produce even more. So where does it end?
Right, right.
So,
I touched upon like this in two answers that I provided, right? So this will be a layered architecture that has to be built. So I mean, there'll be a lot of companies and tasks which needs like millisecond output. And in the new AI native products, they need to happen on the edge, right? And more than if you need some more thinking process to be done, then it has to go to Colo or the larger models on the cloud. So it has to be a three-layered architecture from that perspective. On the investment side, I still feel data centers should go to heterogeneous mode, where they are not just focused on one type of chip, for example. I mean, they should they should have multiple types of chips for data centers. For inferencing, you need different types of compute. For training, you need different type of compute. So it has to be a plug and play sort of a infrastructure building that they need to do in the future. And I already mentioned, like, I feel Plateau will be there in the next 3 to 5 years on training side, and then it's mostly about inferencing for the next 10, 12 years.
so do you envisage all net new type of silicon getting
Yes.
fabricated,
Yes.
designed
I
and
do.
invented for inference, let's say?
Yeah, there are a bunch of them, right? So there is Cerebras, there are Groks of the world, right? So they are coming up. There is a lot of other type of inference chips which are coming up, and I feel there was a chip which was released where model was actually on the chip, right? So and it was giving results in like microseconds instead of milliseconds, right? So new type of chips are coming up, and so data centers should be ready for that.
Thank you for that. And for you, head of the organization, in all respects, AI costs are going through the roof. And I'm sure your CFO must be asking you once in a while what's happening.
Yes.
So, so financial planning and monetization and pricing we touched upon. How do future of cloud or a data center look to you to improve your gross margins and make your company financially productive?
So I think we have to approach this very scientifically, and it's engineering problem to solve. It's not finance problem to solve. So the way how we started is we started measuring to start with, right? In traditional cloud world, it's easy to measure. What is your cloud spend? Right? Generally, it comes from your cost explorer or like whatever the tools that your hyperscaler gave. But when you suddenly talking about multiple hyperscalers, like, and you are forking off from the lot of self-hosted and managed, LLMs, it's very difficult for you to track. So step one is be able to have a excellent observability and telemetry on the tokens going in and out, right? If it is self-hosted, then like, what is the GPU usage, and this should be like a unit metrics. It should be per product, per customer, and per agent, whether it is a AI agent or a human agent, what is the cost footprint across all these areas. So in our case, we have a cost footprint on CPUs, because see, you serve your product first, right? And then AI is used on top of product. So product is first served on CPUs. And then once you start hitting AI, then you start getting onto GPUs. Then you start using some LLMs. Then I may be using Databricks for my data warehouse. So I have to take a cross section of all this for that particular activity and then be able to measure. The measuring is the number one. Once we have the cost footprint, then we start looking at where the bottlenecks are. Because for example, per session, I'm making X amount of revenues, and then my benchmark is the cost should be less than 5% of the revenues you make. So your gross margins are like roughly 85, 86%, then you are really doing really well. So, but right now, in the first 1 year, you may be spending more than you're making, and that's fine, right? As long as you have a line of sight into, somehow I have to get to that less than 10% efficiency. How do you get there? Initially, you may be using Opus 4.7, and then you are burning through your tokens very fast. But once you figure out how to serve this particular model, then I probably have a self-hosted Llama and then be able to serve 1/100th of that particular cost, maybe with sacrificing 10% quality.
Got it.
So each layer, I have to reinvent myself and re-engineer the solution once the adoption goes through. But the adoption doesn't happen, then shelf it, go to the one more feature. So like that, what we have done is, we have accelerated our overall pipeline in such a way that it helps us experiment a lot. And in the experiment cycle, you be able to shelf some or accelerate some. But in the meantime, my team continuously looking at every single dollar and cent that is going in and out. And we have a plan for next 6 months. We also have for next 1 year.
Lovely. Your views, you are a business owner running many companies.
Yeah, so there are two aspects to it. One is AI used in the product, and the second is humans using. I mean, in your company, developers are using AI at this point of time, and people might not know Anthropic has changed its pricing, and that's going live on June 15th. So the subsidy that everyone is providing is slowly going away, and the subsidy is right now around 30x. So, so at this point of time, what we have done is we have actually created our own control plane. So all the developers, all the users of Dragonfruit, they via our MDM we install something, and all of the queries or the LLMs that they are using, all the request goes through our control plane. We figure out that, oh, this team is using Opus 4.7 for just writing email. That's not really required. So we can potentially route these calls for marketing team, for example, to our hosted, let's say, Gemma.
Got it.
For that matter. So there are aspects of this within the product, which Sri mentioned, but there is aspect within the organization, like how exactly you want to optimize that.
Your views, sir?
See, I think like most of the things they have covered in terms of how the developers are using the models, right? So what we are adapting, kind of like we are also having a control. As we are evolving into an AI product, what we are developing in-house. So we also have our own control planes, like where like whatever the usage from the teams who consumes that product. So there will be two directional way. One is like native MCP connected, and it goes to the required systems to fetch the data. And there is a there is a way where like we are using certain models where like we have the API connectivity directly fetch the data from the respective data sources. So in this way, these two approaches, like what we have figured out as a pattern is like this control plane, whatever he was mentioning, like the decision authority lies here, like whether this required a real LLM to take the data out and provide the necessary output, or it's just an API call to get the data from the real data source. So this is how we are reducing the cost on top of the AI and optimizing the resources. That's how we are following an approach.
Thank you so much. We learned a lot about distributed computing, inferencing and training becoming two broad verticals within the world of AI, and both to be approached differently from technology, usability and cost. Then we talked about tokens per watt rather than tokens per minute. Then infinite resource pumping is not the answer. You have to somewhere take a back seat and look at it. And some of the earlier principles got reinforced. Like, this world is in a terrific equilibrium. On one hand, you say it is ever changing, but some things don't change. They only come back in a newer version. The example changes, but the equilibrium remains. Like we saw the example of IBM call getting paid on a success of a matured mobile call. Something similar will follow in the world of SaaS and many others such to follow. So it has been a very exciting conversation, and thank you once again for making time in the middle of your very busy week and a busy day. And I will just ask you 30 seconds each for your last closing remarks till we say thank you to the audience and conclude.
Yeah, so I think step one is keep an eye on what's happening, overall. I think this is my, takeaway. In every AI session that I do is I think the only way to ride the wave, AI wave, is keep an eye in terms of what's happening in the compute layer, like the GPU and also model layer. And on top of model, we are building the multi agent orchestration, the skills, MCPs that are coming in. So that way we know exactly what is required for organizations. But I'll tell you, Piyush, so the stuff that we used to take 6 months for 10 people, we are able to generate that in like 2 weeks with one person now. The amount of skills our team is generating, they are churning out like a normal shell scripts now. And each skill is not to do a certain task of provisioning a EC2. This skill can actually go and provision a full data center full stack. So that scale, we are able to do it. So I think my only takeaway is I think these conferences really help, and I think we have to just keep track of.
One of the leading CTOs, name I will not take here, in Bangalore, made a statement that, Jeff Bezos said about Amazon that if you have a team which consumes more than 2 pizza, that means the team is larger than required. Here this man says, and he says 2 slice team. So that's the future. And he's a known guy, you know him well. I will tell you about the person when we step down. Comments from you, Shivang.
Exactly right, Piyush. So I believe there will be $1 billion companies. It has already started. So there was a company built by a single person with a lot of agents running, automated agents. And it's 1.8 billion at this point of time. And that to revenue, not valuation. Wow. So again, I mean, AI is not a hype. It's real, right. And the efficiency, etc., is amazing. Just keep an eye on the cost, is what I'll say.
Thamarai.
I think what pretty much Shivang said is right. So it is not an hype exactly. So we are in the real world. We are sensing how the AI is exploding. The day by day, we can see that. So one thing I just want to iterate or like probably want to share is like the skill gap what we have. Day by day this keep on increasing. So yesterday whatever we have learned or like whatever we have done, but today if we see like whole a lot of new things has been happened within a time frame of just 1 week or 2 weeks, whatever they say. So the skill gap whatever we it keeps on increasing. So we just want to keep an eye on that. So we want to have a tap on it and keep on start and like addressing the AI challenge what we have, and we have to address with the help of AI, the second thing. And one thing is like AI should not be a replacement, it should be an enabler. So that is what most of the places we try to enforce this to the larger audience, because like everyone should not feel that like AI will replace the entire manpower or the ecosystem. It is not the right way. Like we should consider AI as an enabler, not the replacer. So that is the third thing I just want to iterate. I think like thanks for providing the opportunity. I think I have shared a nice experience with all the experienced persons here. Thank you so much.
So thank you so much for your time, and thank you audience for being so gracious and patient. And we take a bow and have a good afternoon and rest of the evening ahead. And thank you so much. Have a good day.